think
Apparently not.
there's like 3 more people coming.
We'll see. Okay, well, I hope I'm sharing the right screen. What?
How long did it take you when you started college to finish?
So like get my PhD?
Yeah, I'm done.
I started in 2007. So 10 years. 5 and 5.
Five for what?
5 for undergrad and 5 for grad school. Which was easier?
Which was what?
You have to tell me which one was easier, grad school or undergrad?
Undergrad.
Undergrad was harder.
That's kind of
Yeah.
nice. Which I guess grad school is good too.
What's that?
Wasn't it Colorado?
Yeah.
Yeah.
CU Boulder. Because going from knowing nothing to knowing physics is a much harder leap than knowing physics to knowing really good physics.
Yeah.
Wait, which one is it? Undergrad?
Undergrad.
Really?
For me personally, I'm not saying generally speaking. Okay, why don't we have a seat? Okay. I hope this is screen sharing well. Hopefully you're seeing this. We're gonna do a few things today. We're gonna review your annotated papers and summaries. We're gonna discuss what it means to have red flags for credibility so that you can find your own scientific papers. We're gonna assess your assigned papers for these red flags. And then we're gonna talk about how to find your own papers. Because part of this class will be determining a topic that you want to write a proposal about. You will write that proposal and then we will assess whether or not it was good. Right? Did you find out something interesting? Right? Did you find a cool topic based on what the background of the science says should be the next question, right? One of you has reached out to me for your observational project. Please raise your hand if you went to the observatory on Wednesday, but were not contractually obligated to. Oh, that's interesting. 0 out of 0. Okay. Well, no, you're contractually obligated. So, I would recommend that you start the observation or start planning them, start thinking about them sooner rather than later. The very end of today, we'll talk about what your responsibility is. If you're thinking about the total number of hours in this class, I will guess that in the first 3 weeks, right, you've done less in this class than the allotted hours per credit, right? So you still have to do those hours. So you keep waiting, you keep waiting, and you keep waiting, and suddenly you have to do 50 hours of work in the last 2 weeks. And you will get the grade that is aligned to that amount of effort. If you want an A in this class, you have to do the effort of an A, right? It looks like not very much work because we're not meeting in person a lot, right? That's misleading. Okay. The last time I have to say it, or I have to say it again? Say it again. Okay. Say it every single time, right? All right. So let's see these papers you annotated. Where's your summaries?
Summaries or?
Yeah, you have your summaries, right?
Yeah. The summary from the previous paper.
And one that you just annotated.
Last. He wants it.
This is your summary? For the paper that we did last time? The one that you didn't already turn in, right?
Yes.
Okay.
So
So it should look like this, right? This is what it should look like.
wait, I'm sorry, what?
This is a writing intensive class. This is not a doodling class. Okay, so notice that there are words here. They are not just a jumble of thoughts. Everything you turn into me is a communication, telling me what you understood. Right? I'm not reading this and saying, oh, this is correct, right? I'm saying this is the right format. It's written separately, it has a name, it has the word summary, and it has a description. Okay? And then separately, I'll take this one. You're each writing something. Oops. Yeah, you are writing, it's a writing class.
Okay.
More effort, not less. I think you're gonna work together. You're gonna write a summary. Right? But you're each gonna write a summary. On every single one, you're gonna write your own summary. If you're working together to write that summary.
Oh.
Does that make sense? Why that would make? Okay, so let's say you don't understand the paper, you're working through the thing, you're asking one another about your annotated version. But you're going to see things in the paper that your partner doesn't. I don't necessarily just want to hear, what the paper is about, I know what the paper is. I want to hear your ability to scientifically communicate, which is what we're going to try and do. Yeah, and your name will be on both. But whoever's name is first, I'll assume it's the right. Does that make sense? Like I worked with blah 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 on this summary, and that way when I look at them side by side, I don't say, oh, they cheated. Like they talk about the same things because they work together. That makes sense. Right? If you're both, yeah, because what you're also going to do is we're going to be doing peer analysis. Okay, so everyone that you see, right, at some point when we all have them, we'll hand them to our friend. And they'll look at it and go, oh, this is really good writing. I love that you wrote it like this, or what the hell did you say here? This doesn't even sense, right? So everything you're writing should be ready to be presented to someone else. Okay. Anyone need a sticker to go?
So for this summary, how do you get short, right?
What's that?
The summary that we were talking about,
Yeah, you can understand that. That's still a summary, even if it's not perfect. I mean, we're gonna turn them in, we're gonna continue to upgrade them. Yes. Well, and also this one too, we kind of discussed it, as opposed to the next one, which will be your plume one. Right? So the two that I'm about to, you have plume paper in your hands, and you're gonna get the CH4 paper if you don't have it. Or you have the CH4 paper, and you're about to get the plume paper. And you're gonna annotate that one, and you're gonna write a summary. Right? Yeah. Okay. Anyone want to present what their summary is about? Let's go. Whichever one you're prepared to. Yeah.
Are we getting stamps for anything?
No, annotations I just look at.
Oh, okay.
Yeah.
And then are you, next time are you gonna take the summary with me?
Oh yeah, I'll take the summaries at the end, but you need to use them for the rest of the class.
So this is gonna be a summary for evidence of water vapor and evidence of separation in the atmosphere of Mars. Computer models predicted a small pressure of supersaturation in Mars atmosphere. However, spectral measurements of Mars atmosphere were plugged into the supersaturation ratio, and many times the ratio is 2:1. This shows that supersaturation can exist on Mars.
Okay. Generally speaking, you can include any details that you think are relevant. If you want to highlight for your friends or for the other people in the audience, you could say, I thought that figure 3 presented XYZ, and that way you can give some more context to why you either agreed with or disagreed with their assessment. We're going to be talking about credibility today. So at some point, you are going to be forming decisions about what you are reading, right? So we're thinking first as a summary, which is something similar to how we write an abstract or how we write an introduction. You would summarize the state of the field, or you'd summarize whatever the work that you're doing is. And then you'll go on to actually do analysis of that, right? Interpretation. Okay. Anyone have anything that they wanted to add from their own summary that wasn't hit on? Reed, do you want to say something? Yeah. Hey, let's go. Multiple people. Yeah, communicating, right? We want to practice it. We want to practice talking in front of one another. There's very low stakes in here, right? No one's going to laugh at you, hopefully. We'll have to send them out. Does that make sense? Like, go ahead.
Alright, so using the water vapor information collected from the BICAM instrument, this study challenges previous beliefs that Mars atmosphere does not exist in a super saturated state. The amount of saturation varies depending on the Mars solar seasons and indicated by its latitude position. The northern hemisphere of Mars shows a higher column density than that of the southern hemisphere, which attributed that to kind of like lower sea level. And the Martian atmosphere contains an abundance of water vapor suggesting a state of sublimation. And this means that if there's too much vapor to condense onto the available aerosols. And then this research employs a select data set along with the more assess.
Okay, some things we want to think about when we're listening to or when we're like reading other people's work, right? I think both of these summaries were good. They were concise. You're thinking about how do you communicate scientific information. You don't want it to feel too impersonal, or sorry, you don't want it to feel too personal, right? You're not telling a narrative. I think both of them were good at that. I'm gonna read each one of yours. So if you notice, I say something like, you know, this feels unscientific, that's what I'm talking about, right? If I see opinions cropping in that are not in the interpretation part, right? That might be an issue. And we'll, you know, there's just like, it's not really necessarily natural to always write scientifically, but some people have a knack for it. If you have a knack for it, that's fantastic, right? You're gonna go a lot farther. I don't have a knack for it. I'm a really bad scientific writer. So that's why we're gonna get better at it together. Okay. Any questions about the annotation process? Okay. I just wanted to point some things out here. Make sure that we're not annotating the entire paragraph. If you use highlighter for more than like 4 sentences in a row, you haven't learned anything, right? So instead, I also point out like you can use a vertical line and like draw it on there. One, so that it's not too busy, but also indicate what you think is significant, right? Summarize that 4 or 5 lines into, this means, I wrote this in here because of blank, right? So you can do that in the margins, and there's nice margins in here, but you can also, of course, write that in your notebook because you all have notebooks, right? You could like write, okay, this whole paragraph and just write what it means in 1 line. As you go through the process of reading these, you're going to be identifying thesis statements as you move through the paragraphs. So note, right? Good writing has thesis statements and the rest of the paragraph supports it. Poor writing doesn't. So if I look at the first sentence on every page of the paper that I'm reading, do I fully understand it? Probably if it's well written. I gave you 2 papers that are relatively well written, right? Okay. You're already doing this, I hope. Highlight terms and misunderstandings. When you don't understand something, what do you do? How do you solve that?
Look it up.
Google. Yeah, that's a pretty good choice. Yeah. In the old days when we didn't have Google, you literally have to find a book and like go to the index and like find the definition of the thing and look for it. So now you just Google it. I'm totally okay with that, right? And then bonus points for asking the chat, ask me, then I'm engaging with you. I'm like, oh, they're really engaged in the material, right? This is that out of class time work. If you clarify it in the annotated text, right? So you like underline it and you're like, I didn't get it. And then you, in a different color pen, you like write what the thing is. I'm like, oh, wow, they really engaged, right? That's great. Okay. So summaries is practice for writing abstracts. Okay. Things that I want you to hit on. Who gives a shit? Right? What does this work do that's important? And be concise. Okay, this is really the hardest one. Am I saying the same thing over and over and over? Or could I take these 2 sentences and put them together? I just reviewed a paper that came to me about Mars global dust storms. And I can't share the whole review with you, obviously, but there would be times when the paragraph was more than an entire page and then on to the next page. And then another time when the paragraph was one sentence. Wow, I was like, no, this is not how we write. So this is a technique that you have to learn. If you want to become a scientist, if you want to write progress reports, if you want to work in industry, you're always right. Because this is unfortunately how human beings communicate. So you want to do it with technical sophistication. Okay, finally, this is important. Sentence structure, grammar, and spelling are all important. If I put an S next to anything, that means that your spelling is wrong. If I put a G, it means your grammar is wrong. If I underline it with no like happy face or anything, or like great job or something, that just means I don't like it. Okay, I'm pointing it out to you. I'll try not to use red ink because I think red makes people angry, right? Do people like when it's all marked up in red? Oh, your hand came up really quickly. I thought you liked it. Yeah. What? Pink? I can buy some Barbie pink.
Just something easier to see, so I don't mind red or green.
Yeah. I think I put it in-
Charcoal? Purple. Okay. All right. I'll look at pink, purple, and green. You are all going to be printing your own work. You're not emailing it to me. You understand why? Because it gets lost. I do not want to be responsible for people's work anymore. I do this every semester and I'm like, yeah, just email it to me. And this summer I was like, no. I was looking through my email and I see many versions of the same thing. And I'm like, I only looked at the last one. Right? Because they finally bugged me enough that I was like, oh, let me give them feedback on it. So that's bad for me as a professor. If I'm giving everyone feedback every single homework and I miss yours because it's going to my email, that sucks for you, right? Because then all your work doesn't actually get looked at. So that's why we're going to print them all out. We're going to stamp them and I'm going to give you feedback, hopefully before the next week. Okay. Don't ever use the word very. Why? It's a weak word. Very good. What does that mean, weak word? You know, but that's correct. But what is a weak word?
It doesn't really, I guess, like input any more than it would be if you had just removed it.
So if I say it's very cold in here, is that different from me saying it's cold in here?
Not very good.
A little bit, maybe like a smidge, right? But like not in a quantifiable way.
Yeah.
I love you very much versus I love you. Those are the same. They don't feel good, right? Right? You don't want to hear that from anyone. So here's the thing. If you use the word very, it's lazy because there are better words. What do I mean by that? It's very cold in here. It's frigid in here. Different word.
That's a really
Let me introduce something called the source. Okay? You will want to understand the diversity of words that we have available to us if we want to be good writers. In order to be, wait, where did it go? Oh, I haven't written it yet. When we're thinking about the process of writing, we're non-personal, right? And yet we're trying to communicate in the language that we're most used to, mostly English. And we're going to make it, this other form of language is scientific English, right? So we're trying to focus our efforts and be very specific in our word use. So if you say something supports the argument, that may or may not be the same as the data correlates with this phenomenon. Those are two different ways of saying something that might be similar in normal English, right? You might say, oh, I don't have the energy for that. Well, technically you do have the energy for that. You just don't want to do it, right? So specifically when we're talking about, this is why I always try to interrupt you when you're talking in other classes about, you know, is that really the energy there? Is that the torque? You want to be specific with every single term. And that includes descriptive terms, right?
like negative gradients.
Negative gradients don't exist, right? That's okay. We all learn, right? Okay. Another one that I didn't put on here, if you see an instrument, is something like, an instrument on board a spacecraft. You will see this in your scientific writing and you will suddenly become frustrated, or maybe just me, and I'll just die, I'm so alone. Let's say there's an instrument like this gauge, right? And it's on a spacecraft orbiting Mars, right? They install it, they send it to Mars. Is this object on board the spacecraft? Yes. Raise your hand for yes.
How does it get there?
It's just part of it is the answer. Is a ladder on board a fire truck?
Oh. I see what you're saying.
Exactly. That's deep. But the important part to keep in mind here is that we sometimes fall into the mistake of anthropomorphizing science. We take
With the meeting like after these big words, like wait,
subtitles. Okay, anthropomorphization is when we add humanity into something that is non-human. So if I say, look at the cute smile on this tennis ball, I have anthropomorphized the tennis ball by imagining that there's a smile when this is simply a tennis ball. Does that make sense? Anthropomorphize.
Stop.
Yeah, again, anthropology.
All of these.
Oh, stop. Alright. I think it's like this.
Anthropomorphize. Not what I would spell that way. It's PY. There's a PY. There's a Y in between the P and the R that I don't like.
Anthro.
High or, yeah. Yeah.
That's right.
Human fire make what?
It could be wrong. It could be just how it's spelled
Make
correctly.
human. See the word?
Pyro?
Human. If you don't like etymology already, you should learn it. Etymology is the root of words. Where does the word come from and how to break it apart, understand it. That'll help you understand difficult words because you'll know where they come from. Okay. All right. We good?
That actually might be wrong. Hang on.
I don't think there's a Y.
One note corrected me and said that it was the word here, but that's not how you spell it. I'm sorry, I lied. It was like right to your face. So just don't trust one note.
That's the only things that matter. Anthro, human, morph, make. Look up that etymology. All right, so what is, let's go back. What does credibility mean to you? How do you determine credibility?
Trustworthy.
You are using a synonym that is not a definition of how we find it, right? How do we find it?
You look at the person's experience.
Okay, so you look at the person's experience. So you're trying to see, well, does this person know what they're talking about, right? So if I got up here and I told you all about the best shampoo products, you'd be like, yes, I don't know about that. That sucks, right? Right? So that's one thing. What are other markers of credibility? Okay, so do other people agree on that same topic, right? Is there consensus? Anything else?
Are they recognized by other credibles?
Okay, are we talking about the person now or are we talking about the work? Because I'm talking about how do we find credibility in, say, a piece of work? So wait, finish that thought. How do you find credibility in a piece of work?
Organization.
Oh, okay, so where are they from? Are they from, PETA and they're writing about Mars? Or are they from, Space Science Institute, right? Okay, what do you mean by that? Okay, so how was the data collected? Do you agree with the way that the data is collected? Is that what you're saying?
Yeah.
Yeah. Yeah, read.
Like their sources.
Sources, so are the references credible? So not the people who created them as scientists, but in the work, are they referencing themselves 40 times?
Their credibility could come from like how they draw the conclusions from the data they report. So like, is what they're claiming what is actually in the data?
Yeah, that's a different way of talking about like when we generate the data, you know, you create some plot and then you have an interpretation section. Do those match? Right? Anything else? Yeah, sorry.
There's like consensus or like a bias.
Ah, interesting. Okay, so for science, is that gonna exist?
Sometimes, didn't that like representatives just get caught for like doing something? Harvard.
Oh, yeah. I
I think
think
some
it
part
was,
of it was like
Stanford.
part of like some like drug company published something about that drug. Like,
That's not real. Drug companies? Pharmacology? That's not
Pharmacology. So we're talking about, yeah.
Yes.
Oh, okay. I'm sorry, I don't know.
Okay. We're talking about real science, we're talking about physical science, right? But everything else doesn't exist in this classroom.
Yeah.
Biology, not a real science. Okay, you're not gonna be looking up biology articles for this class. What are you writing? You're writing observational astro. You're writing physics. Okay. So there's the question. Do we have a problem with credibility from financial backers? Where?
Like where would we?
Yeah, where do you have to be feel is sketchy, right? You said, you know, there's the issue that maybe money's involved. Where? Where do you have to be actively aware that there might be issues?
Like fossil fuel industries are probably going to make like claims about the fact that climate change is not
Is that
harmful.
physics? Again, I'm simply talking about physics and astronomy in this classroom, places that you will read topics of. Mars, okay, what does Mars have to, why is Mars being questioned? What about Tesla? So you're saying that you're gonna find a scientific paper that's written by Elon Musk?
No, if he funds the paper.
Ah, okay. So you think that he's right, he's funding scientific papers.
Well, like, I think if he did, it might be concerning.
Okay, that's true. There's certainly, you know, you never want to trust a billionaire. It's almost never happens in practice. Papers are not funded by people, otherwise I'd be. You know?
Yeah.
Usually they're all funded by the federal government. What I'm asking you to think about and to reflect on is fields within our discipline that are potentially contentious. What does that mean? That means, are there any places that you might be aware of where making an argument that shows X, Y, and Z would gain you some sort of financial incentive?
Oh,
Yeah.
Well, kind of like the methane paper.
Uh-huh.
Like claims like that there's possible life or like weird sources.
Aha.
Yeah.
Any biological claims outside of the earth are huge financial incentive generation, right? Anytime you see the detection of life, this is enormous. Why? How does someone make money on
part of it's just sensationalizing it. So,
it? Well, fiscally, how does someone make money? What? Nobel Prize? No. You can make money without winning the Nobel Prize. Not even funding to go research. It's more grifter. It's faster. Social media will do what? You can go viral. Your virality can lead to
marketing and money.
marketing. So now not only are you getting a brand deal for whatever, oh, I use this pencil, right? You will see some space influencers working with petroleum companies, working with, you know, people. Oh, I buy this thing and therefore you should buy this too. And then they on their TikToks, they have, you know, 80 million views. And so they just do one TikTok for XYZ company. Oh, it's not that big a deal. You've made money by leveraging your scientific endeavor, right?
You see the, yeah, I'm pretty sure it was the TikTok of Bill Nye, doing,
Stop.
he had like a Head and Shoulders commercial, like. that he was talking
That's,
about.
you understand they're different.
Right,
One of them is scientific communication as a job.
as a job, yeah.
His rise to fame, his claim to fame, is a TV show for children, popularizing science.
Yeah.
That is not what we're doing.
Right.
Okay, so we want to be skeptical where skepticism is warranted. In places like claims for notoriety, that can lead to book deals, that can lead to brand deals, because you've built a name as someone who goes outside of the norm and found life, right? So that's one. What is the other one that happened very recently? More physics-based, less astro-based?
Was it the black hole? Superconductor.
Superconductors.
Oh, that's right.
Right, why are superconductors really important? Room temperature superconductors,
That would be,
super cheap, no loss,
no power.
perfect energy generation, right? Beautiful. Also, safe. So it's really important to look at these incredulous claims when you have perpetual motion machines, when you have cold fusion, right? Creating energy from nothing, superconductivity claims, claims of life, all are red flags, big warning signs, right? Okay, so you see that in your paper, you start reading more skeptical. I mean, you're already skeptical, but you increase the skepticism. Okay, let's see whether or not we got them all. This is what I wrote beforehand. Does the data support the thesis? I think we got that one right. We didn't specifically talk about the error bars. We'll talk about this in practice when we look at the data itself. Does it feel right? Does it have the right vibe? Right? So what I mean by this is you can do back of the envelope calculations. If I told you that in the time that it takes for me to say this sentence, that the average air molecule will encounter 1 million other air molecules and bounce off of it, is that right?
That is the same.
Okay, that's a vibe, right? You could check it. Right?
Unless it was moving real fast.
It's right.
Oh, is it really?
Yeah. But you either know this or you don't know this. And then you'd have to do something like, well, what's the average speed? And then you multiply it by the time between collisions and the density of molecules, right? You could figure this out back of the envelope. Is that right? Or wrong? You have the technique to do that now?
Yeah.
So does it work? Is the thing that they said larger than the total amount of mass in the universe? Is the time that they said quicker than anything has ever done, right? Did they exceed the speed of light at any point in their calculation? Right? These are all questions that you can easily ask yourself. This one here. How does the author and citations influence our feelings of credibility? So we talked a little about referencing. We talked about whether they come from an appropriate institution. We talked about whether they've done any work on this beforehand. Another part here is you can usually tell based on lots and lots of citations if the citations are like, this is bullshit, right? Let me ask you a question. If I have a paper and I look at the citations and it's been around for maybe 10 years and there's 1,000 citations, good or bad? Good.
It's hard to tell.
Why?
Because.
Are they bad citations or good thing? You can't tell, right? So you don't have enough information yet. The citation rate is amazing. 100 citations a year, that's a good paper. However, they might all be saying, this guy sucks. I think, wow, Mateo, awful. That's just the entire paper, right? Okay, so we don't know. You can check. Possible, yeah.
So, I guess in the case where like there is groundbreaking or new information that's being said about a particular field that is becoming verified, is it not safe to use, say, if you wanted to study it or like look into it, like if something's like a volatile thing, like meaning like it's not clear what it is it not worth pursuing or like investigating yourself? Or let other people do it?
What do you mean investigating yourself?
I guess if there's like a there's a claim in your field that like you are a part of, and it's currently contested whether or not it's viable. So like the superconductors that were claimed in South Korea.
Yeah.
Is it worth investigating to either prove or disprove like their recipe, or do you just leave that to other people to like sort out if it's actually a part of the field that you're publishing? I guess I'm saying I'm using that as an example.
Yeah. So let's imagine, right? So let's imagine that we're all material scientists and work in a lab that is equipped for superconductivity. And we see the preprint and it hits the archive and they say, hey, we have this great result. And you read it and you're like, man, that's wild. You know, we could make this in the lab. Yeah. You definitely go and you try to reproduce it. That's the reproducibility argument of science, right? If you can verify it, you get to publish a paper too that says we validated these in a lab. And if you can't, then you get to write out a paper that says these guys did it wrong for X, Y, and Z reason, right? However, me as a Martian scientist reading that, absolutely don't pick up a lab equipment.
Yeah,
Right?
okay, that's fair.
Even if I were a particle physicist, don't pick up a lab equipment. A lot of people will see a problem and they'll say, oh, I can solve it. Specific type of people. And that does not mean that they have the technical credibility to solve that problem. So you'll see some people, they always talk about scientists or two types of scientists. Have you heard about this?
Two types.
Yeah, there's two types of scientists. There are foxes and there are hedgehogs. So foxes, they go from item to item. And when you look around in their CV, they'll have spent 4 years studying this, and then 3 years studying this, and then 6 years studying this. And you can see they have a broad history with a lot of different topics. They're probably using very similar techniques, but they're applying them in all these different places. And then you have hedgehogs. And the hedgehogs sit on a very important problem for a really long time, and they work on that for a really long time. And they're the expert in that one thing. Yeah, right? So Einstein's a great example of a hedgehog. And there's other wonderful examples. Like Marie Curie is a fox. She jumps from thing to thing. The technique she's using the whole time, radiation, right? So there's lots of these examples, and you'll see that more as you start to actually begin to see the same names, right? You say, oh, this person's on every atmospheric paper, even though they're totally different atmospheres. Great giant planets and, you know, Titan and Venus, and what the fuck are they doing on all these papers? Well, they're using the same technique, right? Okay. So the last piece is perhaps the most important. Is it reproducible? Right? If it is reproducible, has it been reproduced? Someone validated this? If it's not reproducible, like you cannot recreate these observations because maybe they were sporadic, you know, like that first detection of dark matter or something like that, right? The first detection of gravity waves, right? It can't just like have a neutron star merger happen again in that same location to make sure, right? So you could say, is that okay in this context? The context of credibility. That question makes sense? People have examples, personal examples, not that they want to share because they can think of, where an observation would not be reproducible but still be credible. Yes? Any ideas? Yeah.
Like seeing shooting stars, like you're like, oh, I saw them, and then it's like, oh, well, they've already passed, and you know,
Right.
you have to wait.
Yeah, something very something very sporadic, right? You might have that. Like, look, you can't go look at it now, but I promise it happened, right? I have this picture. It's the only picture of its type, but I do have the picture. Okay, so that's the question of reproducibility. Now, ideally, even in a transient event, you can make predictions. And you hope that they do make predictions for if this happens again, we'll be ready to look X, Y, Z, right? Okay. So we're gonna look now at each of the two papers that you were given, and we're gonna give you the opposite one. If you don't have it yet. So plumes are here and methane is here. Grab whoever your partner was. Your partner here? Yeah, so sit with your partner.
We're grabbing the opposite.
Grab the opposite one, whatever one you didn't have before.
I don't have it.
Oh,
How did you say? Oh, you could have gone back for the other one. Yeah, later. You know.
I don't know. Uh, yeah. What? Oh, that's okay.
Does that make sense?
Get the other one.
Does that make sense? Oh, yeah. Is that okay?
You're in a group?
Yeah.
Yeah, you're supposed to work on the same one together.
Yeah.
And now you grab the next one. Okay. So I want you to look at these pieces for the paper that you were already assigned. The one that you've already annotated, not the one you just got.
And then
Okay.
save this for our own time, which is the one that we just. got.
Yeah. So then you'll do that under the same context right now. So this is the way you're viewing this new paper, right? Get into it with your partner, ask these questions, see how they agree, look for what you should be paying attention.
Do you want us to turn in the summary we just?
I'm gonna grab it at the end. Cause you might make additional notes, whatever.
I have a question about this thing. It was like weird, like they're, what's it called, like their results are like really different than what I thought it was, right? And like they said it was like around.
Okay, so
It should have happened.
the idea supported the pieces. I mean, as far as how they
Really different from
I'm
what
gonna
they thought.
guess they didn't kind of look. So I'm not sure what the typical.
This is when you are going to decide,
Collection
you read this thing,
or something like this.
does this make sense?
But I'm sure like.
No. So this one, this one is gonna be your next one.
Yeah, so, you know, this is probably saying like, oh, here's the profile of the transmit. Okay, this is this frequency that they're getting, right? So this is like legit that they actually got. What it looked like and then how they're breaking it down, probably with like whatever iterations they use. So I trust this. So does the data support the pieces? Probably. I mean, if I had known how else to do this, I mean, yeah. Like, we're talking about. Yeah. No, I mean, yeah, the thing that they believe it's the source of it is silly, but like,
This is, I don't know if this
They-
is something
they
that like
provided in
would
the,
be something
so
to look for, but like they just compared it to like some random like
metric tons of
place in Santa Barbara.
estimated source. rate
Would that
is
like,
comparable to that.
at least I'm not familiar with what that is. That's something that I would look up to be like,
That's certainly, they're saying
well,
that's.
Yeah, I mean, so this is giving context for it, we can discuss that more, but, you know, if you don't know whether that's a big or a little thing, it's kind of hard to tell, right?
yeah.
So they're saying estimated source strength is comparable to a massive hydrocarbon seep at coal oil.
Yeah.
I think.
I don't know, I feel like this is just like such an arbitrary thing to compare it to.
You know, how do error bars?
Hold on to that thought.
Yeah.
Because that level of skepticism is right for a reason that we're gonna discuss,
Okay.
right? Maybe if you have a different color marker or whatever, you know what I'm saying?
Then again, I'm not sure, what order of magnitude that is, like, this is like saying the ratio of like.
You guys are gonna go with the one that's the same one, right?
Parts per billion, so
That's what you're doing right now.
if that's the
You're taking off-
case,
Yeah.
then maybe these magnitudes aren't that big.
I mean, this one.
Yeah. And so you're saying this is 10 parts per billion, 10 out of a billion parts. This is like this thing. So out of
It's like that.
yeah, so I guess. I don't know, as far as this goes, like the error bars do look large. But like, is that just because they scaled it a specific way? That they look large, like, you know, like, how is, so maybe like, I don't know, I'm gonna say, you know, scaling matters, scale might
Yeah.
explain. Why there are large error bars. So what I mean by that is like, okay, it looks very big, but is it because they exaggerated this axis? You know what I mean? Like, it is the actual scale, like, you know, like, I don't know, like this, and then like the actual scale like super tiny compared to like the scope that they have, so I don't know. As far as the error bars go, I guess I would have to know more about what I'm looking at here. It's like this one, like I'm guessing this is like what, column density? Column density here. So yeah, I would have to know whether or not this scale actually is big or small for the error bars. Right, so we don't, unless like we're expert. I'm going to get it. I would say yes, their data does support the thesis, but their conclusion was questioned. That's what I'm saying. Yeah, and so, you know, if I'm labeling this video right next to here, it's not really a good spot in your column or off the side. I'm gonna say, to credibility, yes. Data. Their maybe not conclusion, their implications are questionable. Yeah, and then
Are they actually
answering
tiny?
you based off of, like, we could put.
I offered Kobe
wow.
cookies and he was like, do you want these like scale cookies?
Bars.
No, I have little cookies. Right, can have them. They have the switch bit.
Yeah, error bars.
Send me to jail, uncredible.
Model. They that.
Think about dietary restriction.
Yeah. But they do appear large. Error bars do appear. That's another.
You don't know
Error bars.
Huh?
You don't know anything about that?
I don't.
No, no, not. Of course not.
To be large. So I guess we have like a general sciencey question, because we're not very familiar with like. Scale for parts per billion, but is the size of these error bars in figure 2 like exceptionally large for maybe axis that it's been placed on, or is it exaggerated? So meaning like the error bars that you're looking at, is that for exaggeration purposes? Or
A, B, or C.
I guess both in A and B for the error bars.
Mhm.
Like, cause if I saw that,
Mhm.
you know, at face value, I'm thinking, wow, they're really off.
What's
but-
really off?
Meaning like the error bars, like, why are they so large is what I'm curious about. And is it scaled? Like, are they just scaling it in a way that it exaggerates their findings a little bit? So that,
Hold on to that question.
yeah, because that's.
We're gonna come back to this. You know, I don't expect you to, right, you're reading a paper,
Yeah,
right? And there are some basic rules that we'll have to talk about when we talk about error analysis later on in the semester.
Mhm.
We'll talk about one of the rules of thumb here. And maybe that'll answer what you're getting at.
okay, yeah. Because it's like, are they just doing this for the audience? Are they exaggerating their error bars so that?
Their error bars will be in the data themselves, and they will be downloadable in the supplemental material.
Okay.
So that would be considered faking your error bars. If you thought that their error bars were not real, that they made up error bars, right? That would be fabricating data.
I guess that's not what I'm saying. I'm
Okay.
just saying, like, did they, so like, I mean, you know, by changing the axis, the scale of the axis, would that at all play a factor into how large the scale bars would look?
Hold on to that thought.
Okay. Because yeah, they all, I guess it looks bad. It looks bad, going across the column density and then going across the mixing ratio for parts per billion. That's how I'm looking at it. For like some of them, it's like, why is that?
Okay.
I'm not saying it's a bad thing. I'm just saying it looks bad.
You like going to smaller functions like my
Not in class time. No discussions of my personal life in class time.
I saw your social media post.
Yeah, right.
Yeah. Okay, so, okay,
What?
if you listen about.
Perhaps, yeah. You remember, if you remember, yeah.
Does it feel
Okay.
right? based
I'll
on-
set a timer.
It almost feels they use very they do that. I guess that, I don't have, so for three, for answering three, I would say I don't have an intuition about like this. Like, I'm gonna trust what they found. Oh, okay, if we refer to it that way. I was talking about like the actual figures, like, I'm not sure if this order of magnitude is right. I'm looking at it and like, okay, what you can be telling me is true. You know? But it is, I mean, okay, even in that scale then, like, if we're like, oh, this is how much methane is actually being produced on Mars. It's like, and it's equivalent to like, you know, an oil rig or whatever in Santa Barbara. Like, I guess that should also like, raise some eyebrows. It's like, whoa, why is there so much on that, right? So, does it feel right? No, but maybe in that sense, the fact that it doesn't feel right is also more valid reason for why it should be looked into or like research. I would say for
Our figure descriptions. I don't know, I haven't read that. This one.
yeah.
It's a bit longer than I would write.
Uh-huh.
3 is probably more comparable to the size of my figure captions. But I wouldn't reject figure 2's caption just because it's long. Sometimes people get in the habit when they're writing where they want to describe the figure inside of the text or talk about the figure inside of the caption, both of which are reserved for the other. Right? Typically, there should be no analysis of the figure itself inside of the caption, but it's not a rule. They're not going to kill you if you do it.
They might comment and send them back to you.
Yes, they certainly will comment, but sometimes you just ignore comments. You know, if you get a comment back from a reviewer and you disagree with that comment, you can just not do it.
Yeah, like who's the mediator for that? Like, oh,
There's an
so-
editor.
Okay, so
There's
the
an
editor has like the final say who's like probably right.
Yeah, it depends on, there's a lot of rules. We'll talk about the review process when we get to reviewing. But essentially, they anonymously contact reviewers, myself included. They send me a manuscript. I read the manuscript, I mark it up, I say, this is garbage, this is good, I like this, make this change, this word needs to be this word, etc. I send it back and I give them a recommendation. The recommendation can be accept as is, accept with minor revision, accept with major revision, reject and encourage resubmission, reject.
Don't write it again.
Literally,
Wow.
don't let them write anything.
Yeah.
Well, that just means like if you say reject, right, that's basically indicating this is not a novel result or it's not credible, right? Because even if the result was novel, like let's say they took new observations and they misinterpreted them horribly, you could say accept with major revision, fix all of your interpretations, right? Reject, right, but encourage submission means go back to the drawing board, reanalyze the data, you could work on it. Reject means no, didn't do well.
You gonna tell us what you grade this one after?
Yes, of course. Yeah.
I guess, so. We didn't do this, well, yeah, okay, so, right, as far as this.
Yeah, practice writing every- You're gonna practice every type of writing, and I'm gonna give you feedback
Because
on
that
them
does
so you
sound
get better.
Right.
Only way
I'm
to
not
get
saying
better
it's
at writing is
like
right.
they found this. they
Sucks.
took it and
You
it
can't
is
hear me and get better.
But, oh, sure, yeah,
Turn
like
it
it
about
happens
Thursday.
now, sure, like.
No, turn it in by Tuesday.
Where it's kind of next Tuesday.
Yeah.
No, for the summer, that was Tuesday.
Yeah, I mean, turn it in as soon as you can. If you see me, give it to me. I don't mind, but it needs to go faster. Yeah. Yeah.
And showing it to you, you don't get to stand it.
Well, I'm still gonna like at the end of today, I'm gonna get everyone's summaries.
And then give you.
No. You'll write it to turn it in either Tuesday, which is when I asked, or he said Thursday, which is what he offered. You're not holding someone to that. But if you turn it in on Thursday, great. Maybe I'll give you a stamp as well, right? But I'm still going to mark up every single summary that I have and pass them back. I'm taking them right now. And I'll take them again on Tuesday, and I'll take them again on Tuesday, and I'll take them every single week. I'm taking writing from you and giving you back writing that you'll need to update. So my expectation, what for that one? My expectation is that when you get the writing back, right, it'll be close to done, or maybe it's completely done. You're like, great. If it needs revision, I hope that you make those revisions and you hand it back to me, and then I'll edit it again, and then I'll hand it back to you. And then you make the revisions and you hand it back to me, and then you get an A, right? So if you turn in a summary, I make a bunch of revisions and I never see it again, that's a C or a D, right? You see my process? Does it make sense what I said? Okay. If I don't see your summary until week 14, also D.
Yeah.
Don't ask that, please. It's not my responsibility.
You can take this. By the way. 'Cause this is like
What?
earlier, notes of what I like.
I can't hear you.
instructed this one.
Oh, C minus or
That way
better.
it's like, we talked about this together, and then this would just be kind of putting the words together, and then. Yeah, definitely use that one, and otherwise, like, starting from scratch, is ridiculous. Because we talked. Yeah, no, so answering 4, how do you look through in citations that links with feelings and credibility? I don't, I mean, like, specifically, I don't know any of these people. I'm sure I could look them all.
I had.
Are we done?
Ooh.
You guys done?
I looked at his time so far.
Does he? Oh, he
Okay.
does. Oh, wow. Like, I guess it's problematic that, yeah.
For what?
Like, the,
It's gonna work like kind of like how fluid work,
Uh-huh.
like if you give us.
Yeah, he's
like
the,
annotations
yeah,
and we don't like give it back. to
the
you
first
correctly,
writer.
then we'll
Oh,
check
damn,
it,
even
check
here.
it,
Yeah,
check
yeah,
it,
yeah.
check it,
Yeah, I didn't do anything. Yeah, so then it'll be worth less.
Yeah.
Yeah, not
Well,
worth
actually,
less, but
Yeah,
worth
see, like,
less.
what-
I want to see the progress.
Yeah,
right,
yeah.
And like, it's perfectly fine with me for you to turn it in 14 times. I'm not gonna look at the number of revisions, right?
But as long as like we're just trying to.
Yeah, exactly.
I didn't like this sentence. It was real like speculative. I wrote.
Okay.
Is that like Well,
These are your annotations.
Yeah,
We're gonna discuss both papers in 2 seconds.
I'm just not sure if this is like accurate for me to say that this is speculative, because I know it's like my opinion on like the paper and my annotations, but I don't know if this is something that is common for someone to write like that.
Yeah, I mean, this is far enough down into the paper itself that you can kind of start to ask these types of questions. Some people, when they're scientific writing, they never put any speculation at all.
Yeah.
Because this is a science paper that is, it's written for the public audience. They encourage a little bit of how does this change the status quo, right? So you'll notice here that they have some context for it. And when you read this one, you'll get a better sense for people at the end of their paper. They said this might lead to X, Y, Z, right? Whether or not that's a good speculative statement is another question, right? Okay, folks, are we almost done checking the credibility for yours, or how much? You're number 3, right? What number are you on for fingers? 2 fingers, 3. Of these questions, have you answered all of them? 3 or 4? 3.
We're getting ready for
4. You're ready for 5. You're on 5, and you're 2 more minutes. Okay.
What your insights and so on. Like a lot. I didn't even see that. That is.
Yeah, but like that was
That's a lot, yeah. I've never signed myself. I've never signed. And the word like you were saying.
I don't know what I didn't know. I think a lot of art.
Yeah. I mean, you write a paper about something, you're stating like facts the whole time, and then you're like drawing a completely different conclusion from the facts that you're stating. You could say anything. You'd be like, I believe it was a turtle on the ground of Mars who ate a burrito. Like, I mean, yeah, like how did it make it into this paper is what I'm wondering. Like who?
We'll talk about that in a few seconds.
Because it's like this is like a reputable journal, so you would think that somebody would go, yeah, but like leave that for other people to decide or look into. But they
We'll
did.
talk about that.
Okay. Okay. I guess, okay, so it could be, I think somebody would have to constantly be checking out a second, see if it's right? So it would be the useful to say like, okay, yeah, so. And we. Could be. Yeah. I mean, well, oh, okay, this is another general Mars question, April 6th, a second. There are dormant volcanoes on Mars, right? I bet, am I right, or am I crazy? I thought there were dormant volcanoes. Okay, so like, could that be like another, I mean, like, I'm just saying, like, you know, why is it, so, okay, sorry, I'm a little bothered by why they were saying that at the end. Because it seems like the other thing would make a little bit more sense, like, there's like all these, you know, it could be anything, okay? But, sorry, that just bothered me.
Bottle up the feeling,
Yeah,
right? It's really important to be metacognitive about what you're feeling.
yeah,
If you're bothered by something
yeah,
and you're approaching it with skepticism,
yeah,
identify what is causing you to feel bothered. We can talk about whether or not you misunderstood it, whether they have a credible argument. But what you're trying to do while you're reading is paying attention to the way it makes you feel.
yeah,
Because if it's tripping some flag inside of your head,
yeah,
you want to know what that flag is so that you can either, if you're right, learn to reinforce that, or if you're wrong, learn to ignore it,
yeah.
right? Okay. So this is why the annotation is good, right? You say this piece here makes me feel, right, whatever, right? This doesn't sound, or this is a blah, right? Something like that.
Okay.
Question mark, right? Angry face, something.
That's the.
When I'm annotating papers, I'm highlighting things and I'm highlighting them with different colors if I don't like it.
Yeah.
Red if I don't like it, yellow if it's fine, green if I like it.
I gotta get pens for this class?
I do all my annotations on the PDF.
Oh, that makes sense. That makes sense.
What? Needs?
Needs.
Oh, no, not for observational. No, we can't because we don't have CCDs on the end of it. And it's really hard to do data analysis with, I drew a picture and then it looked like the moon was like this. And then I drew a picture later and the moon looked like this. I don't.
Oh my God.
Are you gonna send me a telescope to take home?
Yeah. Are the meats the big ones that like are so big?
No. Those are a form of refracting telescope,
Okay.
but the Meads specifically are not the smallest one, it's the medium one that you put your eye up to.
Oh, the ones that get set on the cold. They don't have CCD? Is it just?
You can attach a CCD.
Oh, okay, so it's only like you can only like look inside.
The Meads right now are just visible, yeah. Where they're not for research. If we're gonna do research, we're gonna use the big ones.
That makes, oh, you are, like,
Yeah.
they're ready to go.
No.
Oh, okay. Sorry.
If
Yeah, okay, got it.
Hey, how close are we, folks? What number are you on? 4, 5-ish, 5?
I don't think
We'll talk about that.
Figure, yeah, let's go through like the dark. Supposed, yeah.
Yeah, like, I mean, just like, yeah. They introduced it based off of the needs, what it's called, so that's like how they're modeling, like, right? But I don't know, something that I like those, which is like, those error bars that are horizontal are very large. But it's like, what is that big? It's a compliment. What is big? The big, not so bad. Yeah, by the word error, big error, that's, yes. I don't know. Yeah.
Okay, folks, so let's pause right here. We're gonna break down the next one, plume paper credibility. Number 1. Does the data support the thesis? Who read the plume paper?
In the middle.
Okay, so this group and this group.
Yeah.
All right.
Alex is a plume. I'll say that. Good boy.
Do you think it's not sufficient enough?
Okay.
Because they're,
It's kind of like the two films that they even have to spend it 10 days, but the data set they use is about from 1 or 2 days. So it's like that's not enough to.
Okay, so to quickly summarize, there is a claim that observations of Mars, which look like this here, that there's this like big bright spot, and that is a cloud. And so Giselle's saying that even though they claim that it spans 10 days, you're saying that they're only demonstrating 2 days? Is that correct?
Yeah.
And so therefore, their argument of 10 days doesn't even support the pictures that they've included.
And they also mentioned two rooms, but they don't go into detail about what
Okay, okay.
we do.
Yeah, so they do this over here. They say that this is a 1997 apparition. That means when I saw something. And this is the 2012 apparition, when I saw something. In which they don't even discuss this one here in detail. They only talk about the one on top. Is that correct? Is that what you're saying? Okay, so that might be a little bit of number 2. How do you feel, not this group? How do you feel about the error bars in this fit in figure 2? Or figure 3.
With the 97 one, they seem pretty believable. You know, air bars aren't too crazy. The model was pretty close.
Let me show you.
For the 97.
Anyone doesn't have this? Everyone's looking in their own work, right?
Yeah.
Because you have it all in front of you. Yeah. So to clarify here, the green is a model of dust. The blue and red are models of water and CO2 ice respectively, and the data is in black. So Jose, your argument is that 97 fits well.
For 97.
Does it fit one of those 3 specifically well? Dust, water, or ice? Sorry, water or CO2?
The water.
The water one. Looks like it fits the water pretty well. Okay, for the 2012 apparition. Or not?
Because the error bars are like plus or minus 0.01. That's pretty significant here.
There's a couple really important things that Jose is doing, right? He's identifying what is the signal to noise ratio. So he's looking at the value of the signal, and then he's comparing it to how wide those error bars are. If the error bars are approximately the size as the observation itself, that's garbage. Okay? We usually want them to be at a minimum 3 times as small. So here the value of the data is 0.05. And he said, well, the error bar is about 0.01. So that means the signal, 0.05, divided by the error, 0.01, would be 5. So this is potentially a good observation. The data itself is good. Now, one thing that he hasn't yet ID'd, and that I'm going to point out here, is all 3 of these points are from basically a tiny little piece of this waveband. And they don't tell you anything on the left or anything on the right. So you could drive a truck through those. Right? That is not a good thing. And we'll talk about what is a good thing later on. Good, so we got the first 2. Oh shit, does anyone have a Mac battery? I did it again.
One day the spring time, it'll be here, yeah.
I'm gonna remember. Next Tuesday, I'm gonna remember. Maybe. I'll just buy it for one for each. Okay. Does it feel right based on order of magnitude?
I think no, personally.
Why is that?
Just because it says that they're normally seen around below 100 kilometers. And these are almost like 100, 150 more. So it does just set off an alarm. I'm like, oh, that's pretty significant thing.
Yeah.
It doesn't feel right. I mean, I still haven't finished making stuff.
Okay. But it doesn't feel right. Okay. This one's gonna be harder. You're not gonna have that intuitively, right? You'll get better at doing that as you work. But how would you check the citations? What? Well, where do you find that? On Google Scholar. There you go. Yeah, I just need the whole thing, right? So we go to Google Scholar, we look at the citations, we click the citations buttons, we open the citations. Good. Is it reproducible?
Not easily find.
What? What is reproducible?
Like, can you get the same results again?
Yeah. So remember that when we look at observations, right? Sometimes transient things happen. If I go out and I look up at the observatory and there's a cloud above the observatory and I take a photo of that, right? I may never ever see exactly the same cloud in exactly the same location at exactly the same time. Does that mean it's not reproducible? No. Right? That means that I might make a supposition that under these conditions, temperature, water conditions, that clouds form over the mountain. Right? And then I'll go look at those times and I'll see if there's a cloud. So it might be reproducible, right? But
Is it considered reproducible if in the like very first paragraph, it says 18 observers employed use different telescopes, like different wavelengths and saw the same thing?
very good. Okay, so now we see that it wasn't just one group that did it. So people all over the earth saw it. So that's very helpful for the credibility, right? And there's another piece in here too.
Yeah.
There's another time. Right here, there's 2 times. So it might be reproducible. Unless 97 is for some reason not right. Right? So the fact that they include 2 times, they said this isn't even the first time that we've seen it. Maybe it is reproducible, right? Okay. Okay. So the data appears solid, but the raw version is not made available. You have to dig. You don't know that, but I do. This one here was underwhelmed, right? They didn't discuss the things that we talked about, the fact that you can drive a truck through the air bars, right? This one's big. This would be off of the planet. The atmosphere itself ends at about 200 kilometers. The lowest altitude they found was like 200, 250. So this would break physics. We don't like that, right? Big red flag. The author is well established. Okay. The citation count is good. It's fine for a paper of this type. Okay, so not that controversial, according to the literature. If you talk to Mars scientists, it's quite controversial, but no one does. The first one says the 2 observations are different, separated by years. If you go into the supplementary material, you'll see that the first one is probably something else. Okay. Cool. It's probably something else.
So.
Credible or uncredible paper?
It's more like.
Fingers. Up, down, medium.
I mean, it's something good that you could investigate into, you know, verify it.
Okay, right. So you could say something at the end. You can say, hey, we should look, right? And like pay attention to this part of Mars, maybe something funky will happen. Right? That's a way of checking the future. Right? So most of you would reject this paper, is that correct? Can you explain what is going on? Not read.
Is it dust particles?
It's not quite that easy. They are clouds, but they're at the wrong altitude.
Oh, okay.
They made a mistake in the data analysis.
Okay.
You'll never be able to see that from the paper. But all the red flags, all the warning lights should be going off because their claims are not supported by your intuition, by your feelings, by the vibes, right?
Was this updated later on?
No, we're writing a paper right now to tell them that they're stupid.
Oh, wow.
Okay, this one. Okay, methane.
Yeah.
All right, let's go back. Let's think about this one. You three now are on the spotlight. Does the data support the thesis?
Final something about strong release of nothing. One sensitive with tense, I guess, it's strong.
Mhm.
But at the end, when you're talking about how much of it there is, they call it an estimated. Hypothetical field, where they estimated how much, that you want to have to. It's like how much.
Sorry, say that again.
I was trying to find in the paper where this is how much of it there is.
Yeah. Yeah, so that second to last paragraph, is that what you're saying? You're saying that the methane plume footprint would be smaller by a factor of 1600, is that what you're talking about? And that's not really that strong?
When they were trying to talk about how much of it there is,
Yeah.
they called it estimated. And like.
Oh, yeah. I mean, how would you compare those two numbers, right? So it says if seasonally controlled, the duration of release would be substantially shorter than the 0.5 mega years, requiring a mean CH4 release rate. For comparison, a hydrocarbon seep field in Santa Barbara releases it at 0.4 to 1 kilograms per second. So this is saying that 19,000 metric tons of those is released, right? And that this is about the same rate as a terrestrial source, maybe half of a terrestrial source. And your argument is that's not really that strong?
No, just that. I feel like if you wanted to say it was strong, I like there's ways you can measure how much it was instead of just bounce back to line which one it was and estimate.
Well, that's kind of how you decide. But I mean, what they have is they have these like maps, right? And they try to add up all of the stuff in that map. And so they'll take a line through the location and then they map it onto the surface and they assume that if you have some column abundance, how much is in the line of sight, they can grab that out. And they say, well, if I add up this bit, this much and this much and this much, then I get that 16,000 pounds, right? That's their estimation. Does that make sense? You still feel like that doesn't support their argument? Okay. Anyone else?
I thought, their thesis is supported by the data.
What?
So, I mean, I'm not an expert, but
No one here should be.
yeah,
for me.
but, I guess by what they're presenting in the figures, it does look like they have captured, an instance of an excessive amount of methane. So there's like no claim to say that that wasn't a lot, that is, and the fact that they're relating it to like something that is a rate of production of methane here would show that is abnormal, since there is not like an industrial oil based factory out in Mars. So it is suspect that there would be something and would cause like eyebrow raise of why it's there, but
Yeah, so you're jumping ahead.
yeah,
Right, but
okay.
because their data support the thesis, so your argument was,
Yeah.
well, there's a industrial quantity of methane on a place that doesn't have industry.
Yeah.
Right? And maybe, I mean, we acknowledge that we're not spectroscopists, but we looked at this data and, like you can see here at the bottom, that this dip is that dip, and this dip is this dip, and this dip is that dip. So the data do be dating, they didn't fake this at least to first order, right? You're looking at it and you're like, data looks like data.
Yeah.
Right? Now, what about the error bars? Someone who hasn't talked yet. Yeah. Mhm. Like if the data is doing this, the error bars get bigger too. So if the data points are getting larger, let's say you're measuring the number of counts, and they start over here, and they're proportional to the number of counts. Then as the data got more, the error bars would get larger. But that is not always how error bars are constructed. They are a combination of random and systematic uncertainty. And depending on how you add those two different things, sometimes they're uniform. Sometimes they get smaller and bigger. When the data goes up, they'll get smaller for different reasons. Okay, error bars.
I think it's just a question.
Yeah.
So is there a error in the way they, I guess, found their error bars? Because it just seems like it is very large. For some.
What do you mean very large? So some of the things that so let's look now at figure 2, specifically A and B. And you're looking here A and B. Some of the questions you want to ask yourself. Okay, so this black line in the middle is CH4 mean. So the mean of the two bands. And it shows one band versus the other. And are they roughly doing the same thing?
Yeah, like this exact sort of.
They're kind of zigzagging the same. So the data points themselves are going in the right direction. The uncertainty is supposed to be probably proportional to how much you're seeing. So we don't quite know what that proportionality is. So we can't quite assess whether or not in B, data third from the bottom with really small error bars, whether that is reasonable compared to the one that is slightly below it, where the error bars seem to be larger, right? We can't assess that. But what we can assess is whether or not you have individual points that seem well outside of the norm. Does something look like it's 3 sigma removed? And the way that you can have this conversation with yourself is, what is the word 3 sigma mean? This means that if you have some distribution, right, like this, and in the middle is the mean. Some values will be higher, some values will be shorter. Okay. So in a distribution of people in the room, there will be one person that's really tall and one person that's really short, and most everyone around the middle. If you get a lot of people together, say 1,000 people, one person can probably play in the NBA and one person cannot, right? And everyone else would be fine on the field. Okay. Here, you don't quite have enough points to know if that's the case, but that's something you're going to be looking at, right? So I look at this point here, and I say A, B, this one that's third from the top, it's kind of outside, right? Oh, is that a problem? Well, there's about 10 points here, maybe 20. 1 or 2 can probably go off, right? So I'm like, okay, that's fine. So maybe the error bar in the model is good. Okay, maybe, but I'm worried. Okay, next. Does it feel right? Someone who hasn't talked yet, this group?
It might appear right, according to the data provided, but it doesn't feel right.
Why doesn't it feel right?
Well, I'll explain it, but it does say in table 1, it does say that it's a data.
Yeah, right. They only showed you the data where they saw something, right?
Yeah.
Okay, interesting. Okay. It doesn't necessarily feel right. Okay. Anything else about it raise any red flags? I think Paolo mentioned something.
Yeah, but I can't find it.
The bottom of that page. Sorry, flip it over. Flip it over one more time. One more time. One more time. Last page. At the bottom, on the right-hand side, second left. Yep. Yeah, lower.
Oh, it said that something like this should happen every 350 years, because they're used to happen in like 6 years.
Yeah. So what he's talking about there is that methane is long-lived. That it is destroyed by ultraviolet light. And the lifetime for it to be destroyed is 350 years. So once you make it, it goes and it just moves around the whole planet. And they're saying that they saw it destroyed in roughly half a year. So that's the order of magnitude that you identify. I don't know. Seems like new physics, right? We don't like new physics unless it's right, and then we love new physics, right? Okay. Anything else? What about this last piece? You can't really do that, right? You don't know who Mike Mama is, but you might know the second name. That was my postdoc advisor.
Oh, man,
So
that's why I was.
he's gonna come visit in October, and you can meet him and go to his talk. So you can be like, hey, I think your shit's fucked, man. No. All right, and then the last one, is the work reproducible?
Again, it's something that we talked about a lot. With like seeing it, seeing like the parameters of which it happened under, and trying to watch that every.
Right. Okay, so let's see what I wrote. Okay,
Tesla.
data appears solid but complicated, right? Not easy to get into. I don't know. Error bars, yeah, okay, whatever. Where does the CH4 go? That's exactly what Paolo said. I wrote these before, right? The author is well established. Mike Mama's fine person, human being is good, as a human being-ish. The citation count is huge though.
Yeah.
Everyone has an opinion on this. Why does everyone have an opinion on it?
There's something that happened over 350 years that happened in half a year.
That's not the controversy. You're right that that becomes a paper. Frank Lefebvre shows that in fact there's no way to destroy that. Yeah. Life. Who for why nothing? Who for why? Who for why nothing? Yes, five. Doing. Arcade. Yes. So something like 80 to 90% of Earth's methane is produced by cows farting. Sorry, of the biologic, there's geologic methane too.
Yeah.
But a majority of the methane that's produced biologically is from cow farts. Okay. So the argument here is that they have found something comparable to
Space chemicals.
space farts. And it's the size of an industrial fart on Santa Barbara, right? So controversial. Further interpretation, someone could say, well, it's not present life, it's subsurface life that was similar to, they make this conversation about the permafrost. This is in fact not present life. Permafrost is stuff that was alive, okay? Grass, vegetation, then covered in snow quickly, and then packed under that snow. And so it becomes methane as it degrades, but it's trapped under the surface. As that permafrost thaws, it releases the methane again. So that's the analogy they make. If you use that analogy here, then the obvious interpretation is that there must have been grasses on Mars that are unseen, and now they've been released. Right? Grasses, grass, plant, vegetation. Right, life. I use the word farts because it's funny. And then the idea is that anything that is alive and breaks down, so in your gut, There are microbes breaking down the material to make methane. The plant material that's in permafrost is broken down by microbes. Does that make sense? That makes the methane. Is a byproduct. Okay. And since then, there have been many observations. Some from the ground, some orbiting, some from landers. Some of them agree, some of them don't. Incredibly controversial. Is there methane on Mars? Raise your hand. Like this. Look down. Right. Are you doing the publishing of this paper or no? Yes? Anyone else? Mediums, you don't want to choose new editor? Yes? Publish? Publish doesn't publish. Yeah, from this paper. Right? Yeah. So you're the reviewer, right? You just heard this whole discussion. You're looking at it. You're the editor. You're like, do I press the go button? You want to? Okay. Down. Okay. No one liked it. Okay. All right.
I mean, it got published.
It got published. Both of these ones that you all hate got published. So what does that mean? That means science broken?
No.
No, science not broken. This is the process of science. You peer review because you can't find anything wrong with your own work. Even all of your co-authors agree. And you send it out to the reviewer, and the reviewer agrees. And then they publish it. And then everyone piles on and says, "You fucking idiot." Right? Oh, I get irate. Very angry about it. Okay, have you ever heard this? What? Extraordinary claims require extraordinary evidence. Okay, what does this mean? This means that if you're going to make a statement about new physics, you're going to make a statement about life on other planets, if you're going to make a new statement about superconductivity at room temperature, you're going to make a new statement about finding stuff from outside of our solar system on an ocean floor in Guatemala. If you are going to make a statement, that was the Avi Loeb, the Harvard scientist that you talked about. That's what he did. That's what he claims to have found. He found normal things. And he claims that they're from outer space. No. So you have to have extraordinary evidence, and it has to be incredibly compelling. These two that I've given you are incredibly compelling because they are not obvious why they are wrong. And that's why they persisted. That's why they made it through. Okay. What alarms go off? We already talked about that. Why is controversy a great place to look for science? Because the data is real, right? So either something's messed up with their interpretation, or there's a new physics to be found, right? So exactly what Paolo was talking about. How did this thing go from 400 years normally to half a year? Maybe that's a new physical phenomenon that we can investigate, right? Okay.
Has it been investigated, or is this still?
Sorry, we're gonna continue with that. Okay, so if you haven't started, start reading the book for the CCD if you're going to be doing the astronomical project. Plume people, read the methane paper. Methane people, read the plume paper. You can disagree with what we've talked about here, but you're going to read it under that same type of skepticism, right? The new task: find an astronomical, planetary, helio, or earth science topic that interests you. Use Google Scholar. Find a review paper that you deem appropriate using the metrics we discussed in not last class, but the class before. Okay. Submit this paper and your reasoning by next Tuesday. Yeah, you're gonna send it to me
Before class.
before class. So I can be like, that's not an appropriate paper, don't read that. Right? I'm gonna read it, make sure that it's okay for you to read. You can't pick something like relativistic black holes. I'm gonna just let you jump into it. You'll be completely lost. You won't have fun, right? No, you won't have fun. Yeah. No. You won't read it. You'll find it, and you'll determine whether it's a good paper based on the things that we talked about. And then you'll pitch it to me.
So, yeah, it's kind of been Not my sister,
No, no. Determine whether it is a paper that does the things that we talked about before. Is it well cited? Does it come from a credible institution? Is it a review paper that looks easy to read, right? You don't read it already and then tell me whether or not you can read it. Yeah. Okay? Okay. The other thing that you need to do, you need to decide what you are doing for your project. And you need to do that now. Okay, you're going to be working in your own time to be taking observations, and we'll start to do the data analysis later on, but you need the observations in hand. This particularly if you have a time-sensitive observation. If you are attempting to look at Jupiter or Saturn, there may be a window in which you can do that. And that might disappear if we start having rain. Right? Do things when you can. So what you're going to do, if you want to do a project on any of the things we talked about last Tuesday, you talk to other people in your group, see if someone else wants to do that. I will let between 2 and 3 people work together. 4, you're not really working together anymore, right? You can share data, but you have to analyze it separately, right? Kobe already has an idea. If you don't have an idea, come to me and we can talk about the ideas. Hey, I'm just trying to join the only one. Okay? Questions, comments, concerns? Okay, thank you. Yeah, that's it. That's it. You have to have a project next week.
You could put the PowerPoint slides on the
Yeah.
Slack or.
Yeah.
And I'm also wondering